All of you should know how to find the tangent of a straight line. In this video, we are going one step ahead and learn how to find the gradient of a curve. So what you are going to learn in this lesson is how to find the gradient of a curve. The key is draw a tangent and dy dx, which is the formula for gradient of a curve. But first, what is a tangent? So let's say a quadratic curve looks like either the left or the right, depending on whether x squared is positive or negative. So for a curve, the gradient will obviously be different throughout. For example, over here, you can see the gradient is very steep, while over here, the gradient is less steep. Over here, the gradient is very steep. Over here, the gradient is just smoothing out. So it's not as steep as over here, where it is going very high up. So let me just erase. And a typical question will ask you to find the gradient of curve when x is equals to something. Let's say they want x to be down here. A tangent is basically a line that just touches the surface of the curve. So what I mean is this: the line just touches the surface of the curve at the side where they want us to find the gradient. So let's say over here is x is equals to -2. So we need to find the gradient of the curve at x is equals to -2. We draw a tangent down here. Let's say another part of the question asks us to find what's the value of the gradient when x is equals to, let's say, 4. Okay, x is equals to 4. What's the gradient down here? Let me draw a line. Is this correct? No, this is incorrect because a tangent is not supposed to cut the curve. It is just supposed to touch the curve like this. So a correct tangent should look like this. It just touches the curve. How about if the question asks us to find the gradient of the curve at x is equals to that? Is this line okay? No, it's cutting through the curve again. It is not supposed to cut through the curve. It is just supposed to touch the curve like this. So you cannot say like, oh, they want us to find the gradient down here, then you draw a line like that. Cannot, okay? You might as well just draw a line like that. It doesn't matter, right? Cannot. It must follow a format, and that is the line must touches the curve. Just touch, not go through. Alright? You can only touch, you cannot go in. So let us take a look at the first question, or rather question 4. I'm again going to use graph 4 to 6. You can practice them. So we are supposed to find the gradient of the curve at x is equals to 1, as well as gradient of the curve at x is equals to 4. So what we are supposed to do is to draw the tangent. So I will show you a quick demonstration of how you can draw a tangent to a curve. The point where we are interested in finding out the gradient of the curve is when x is equals to 1 and when x is equals to 4. So let us start with when x is equals to 1. We need to draw a tangent down here. So like what I said, a tangent is a line, a straight line that just touches the curve. So I can do it like this, or I can do it like this. But I would not recommend you doing it this way because you cannot have a good view of what it is cutting. So ideally, you want to place it along the curve. Then you do a rotation to just make sure that if you put like this, it is touching. So what you want to do is to place it down here and rotate
until you are satisfied that it's not touching any part of the curve. So I think it's alright, and it will be good if it's passed through some nice number. It will be easier for you to do the calculation of the gradient. So from here, I draw a line. So after I draw the tangent, I need to pick two coordinates. The first coordinate is, by default, I would suggest picking this point, because your tangent must pass through x is equal to 1 and y is equal to -2. So after picking one coordinate, the other coordinate, it can be any number along this straight line. It will give you the same answer. You can pick here, 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 or even here. But what for pick a difficult to calculate number, which is why earlier on I said pick a number that's easy, or pick a line that pass through a or some nice number for you to do calculation. Even if it goes out from the axis, we can just add. But of course this is not given, or rather this doesn't happen all the time. So this time around we are lucky. If not, you can just pick this point. You will get the same answer. So over here is 5, -6. So you can use these two coordinates to calculate the gradient of the curve at this point, which is x is equal to 1. Next, we need to draw a tangent at x equals to 4 to find the gradient of the curve at x is equal to 4. Again, do not draw the tangent like this because you are covering your curve. Instead, turn it around. And align it so that it only touches the curve. Once you are satisfied, draw a line. Alright, so you can see that the tangent only touched the curve at this point. So we can use x is equals to 4, 4, and over here is 2, -6. So we will use these two coordinates to calculate the gradient of the curve at x is equals to 4. So that is how you draw a tangent for us to calculate the gradient of a curve at specific point.
After drawing the tangent, it should appear something like this for part 1. So after we draw the tangent, what we have to do is to label two coordinates on this tangent. What I like to use is default. I use this because they already tell us x is equals to 1. It will definitely pass through x is equals to 1. And the y coordinate is -2. I can pick any point along this line. For example, here or here. This one is way off. But I can of course add a -6 and I will be fine. So let's say I want to use this point instead of this one. Normally I will just use this point, but for the sake of showing you, I can use a value outside the curve. I will just do this. And to be honest, this is a bit of luxury because there's enough space. Normally, you will just go by this within the confinement of your axis. So part 1, find the gradient. So I have two coordinates, 1, -2, as well as 5, -6, dy dx. So -2 minus -6 divided by 1 minus 5. So this will give me 4 over -4, which will give me -1. So gradient of the curve at x is equals to 1 is equals to -1. And for part 2, you should have this line or this tangent. Again, I will use the coordinate of x4, and when x equals to 4, y also equals to 4. So I will just draw this line until I reach a nice number that I can use. Over here is 2, 6 or -6. So what I have is 2, -6 over 4, 4. So -6 minus 4 over 2 minus 4. I will get -10 over -2, which will give me 5. Alright. So this is how you find the gradient of a curve, by drawing a tangent. Tangent only touches the curve once. And you can really use any coordinate along the tangent. Just that I normally like to extend the tangent until it reaches a nice number, so I can have an easier time doing the working. Whichever point you pick is up to you, but my advice is really pick some number that is nice to use. For question 5, we are supposed to find the gradient of a curve when x is equals to -1 as well as x is equals to 2. So take your time and draw the tangent, do the dy dx to find the gradient. And if you need to check your answer, they are down here. If you can't get the answer, maybe your curve is not smooth enough, please redraw it. But if you think your curve is smooth enough, then please check your tangent. Are they being drawn correctly? Are you using x is equals to -1 as one of the coordinates, and x is equals to 2 as one of the coordinates to find the gradient for each respective part of the question? Then for part 2, the line that you drew should look something like this. Then do the dy dx, you should get the answer. For the last question, last practice, please do it on your own. Draw the tangent, do the dy dx. And here are the answer. And one way of checking your answer is, at -5, you can see the curve is going down. So obviously the tangent is negative. While for -1, you can see that the curve is going up already. So your answer should be positive. And that will be all for this video.